Let's move to our other model, and because people are different, the number line method doesn't work for everyone. I do like it, but you have to know your audience, and if this just doesn't stick, just, I don't know, for some reason, the kid just doesn't like it. What else can you do? So it's worth introducing another seemingly very different model for this basic arithmetic called the chip model. Now I can't stick chips here, I'll just draw them. So you have to originally start in every question saying what is your positive chip going to look like. So let's make it yellow for positive, because red is a little negative. So I'm going to just use an open circle for a positive chip. And a negative, so it's not a 0, it's a chip. Negative will be colored in circle. There are no numbers in it. So you can choose, of course. And in the beginning of a quiz question, you have to start with saying, this is what my positive chips look like, and this is what my negative chips look like. Otherwise, I don't know. And I don't want to decipher and guess. So let's just make it all consistent and say yellow for your working example will be positive, red will be negative. So how do I use this intuitively to, did I use 3 plus 2 again? I did. Anyway, whatever. To do the variations. What are the basic variations? 3 plus 2 is obviously the first one. Not with these numbers, but basic addition, all positive. So that's going to be my first quantity, 3 positive chips. And my second quantity, 2. Put them all together, and I'm really just putting them together and counting them. That is extremely basic, and that's where you start. Put them all together. There's no catch, there's nothing strange. And you can see there are 5. Absolutely nothing to it. You can give this to someone in kindergarten. Totally fine. They might not write the numbers yet, but they can definitely say them. So nothing to it. Then basic subtraction with a positive answer. Now I'm going to start with my 3, my original number, my first number. And I'm taking away, take away 2 of these. So these are gone, take them physically away. I'm left with just that chip, and therefore the answer is 1. So writing this on the board is what I have to do, but of course to kids they respond much better to touching tokens and things like that, flipping them, whatever. So basic subtraction is still fine. We'll come back to this in a second, where my answer is negative. Let's just make some space here. Let's go with 3 plus negative 2. So I am still putting stuff together, because plus means add stuff together. So I have my original 3 positive tokens. Then I have my negative 2, so that is 2 negative tokens. And I'm putting them all together. Putting them all together. So together, I have 1, 2, 3 positive tokens, and I'll just line them up here. A negative token and another negative token. The only key here is that if I have 1 positive and 1 negative token, they cancel each other. Cancel each other, and I have only 1 left. That is, I guess, a rule. It is intuitive when you think about it, I guess. A negative and a positive, and they together can be removed from the table. What else do I have? 3 minus negative 2. Any questions on that one? Positive, negative, 1 to 1 can be removed from the table. Now for this case, 3 minus negative 2, I start with my first number. That's not going to change. Now I'm trying to take away, let's write in words, 2 negative tokens. But I don't have any negative tokens to take away. In order to bring in some negative tokens and not change the quantity or the value of the number, I have to bring in a negative with a positive. Negative, I'm going to swap them around, sorry. Negative with a positive, because that is really nothing. Because they cancel each other. And I'm going to do 2 of them because I want 2 negative tokens to take away. So I will then take these away. And I'm left with 1, 2, 3, 4, 5. So the answer is 5. To me personally, this feels less intuitive. But everyone's different. And to some, this might feel better. So it's good to have some options in your toolbox. Any questions or comments on that? Different. Better? There's no answer to that. Everyone's different. Could be better, could be worse. Whatever works. Let's just change this a little bit to say 3 minus 4, let's say. Just to make sure I cover all the variations. And then we'll just practice. So I start with my first number. 1, 2, 3. That's what I have. I'm taking away 4. I don't have enough to take away. I'm taking away 4 positives. 4 positive tokens need to be removed. How do I bring in more positive tokens? A negative positive pair. Now take away, I'll write it in words, 4 positive tokens. So that has to go. And I'm left with, clearly, a negative token. Very different, but it's nice. Depends if your audience likes it or not. I don't know. And it really depends on what you see for the first time. If you see this for the first time, it'll feel much more natural than the number line. I think most of us have seen the number line first in our own education, and that will then probably feel more natural. Comments on this? So there is a method here as well, underlying rules to follow that would lead me to the answer. It's not random, and it's not completely intuitive. Once you have the one-to-one pair that you can introduce or take away as you wish. So let us, how much time do we have? We have some time. Exercise 12.2. I'm going to skip number 1 because we've done it, and do number 2, 3, and 4, and you can work together at your table until you're confident, and then come and show how the chips are used to find the answer. 1 plus negative 4. So we'll have 1 there. So let's just do that one first. Someone comes to volunteer and show how Timmy should use the chips to find the answer. Oh, she's fast.
Can I technically use a different key for the positive, negative?
Oh, if you want to use a different key, you just update it there. Whatever you want to use, you can As long as you start by writing what your positive and negative represents, you can do whatever you want to do. We have calculus after this, I'm already eager. Calculus has that effect. So she flips it around because that's what she wants to do. As long as you say positive is now the shaded one, negative is the empty one. That's fine. I guess it makes more sense, right? Negative, empty. I don't know. Doesn't matter. Just remember to start with that. So you have your. Oh, you have 4 negatives.
Whoopsie.
That's okay. For me, the chip model needs a little more practice because I'm not used to it. That's not how I was taught. Feels a little less intuitive, but some people might respond better to it. It's hard to say. All right. Obviously, the answer is not the challenge here in any way. So I want to show my cancellation. Let's put it this way. Let's put it this way. If little Timmy reads that, or looks at that, does he know how the chips were used? Of course, Timmy could be really bright, right? In general, average Timmy.
Oh, no.
Probably not. Probably not. Because I haven't really done anything. I've really just copied the numbers and gave the answer. I haven't actually used the chips. So I want to show it just a little more clearly that I'm putting together all of these. That's not my answer. But these cancel because it's 1 positive, 1 negative, and therefore my answer is 3 negatives. So just do a little bit more to show. It's hard to do it on paper. Of course, you would demonstrate with the tokens and walk me through it. So we're now skipping that. Just a little bit to show me at least that you understand the chip model. It's not just copy, copy, answer, because then I can't tell for sure that you understand how the method is used. That's the trick. That I want to give you the marks, but I just need to see that you understand the chip model. This doesn't really show it, even though in practice you would have the chips, of course. But I can't take everyone into my office and walk me through this chip model. It will just take forever. That would be nice. I should do that one time. But it puts a lot of pressure on you, right? You're on your own there, I'm looking at everything you're doing. Not everyone likes that either. So just write a little bit more to show that you definitely understand the chip model. Now don't criticize it, we're learning. And in a quiz, you can of course ask me, is that good enough? Did I show enough there? And I can tell you yes or no, but that doesn't reveal the answer. 3 minus 5. Number 2. 3 minus 5. Who feels like volunteering? Now, of course, no one is because I criticized her, but it wasn't criticism. She did it right. It was just, I wanted to see a little more to be absolutely sure you know how to use the model. I know you do, I just need to see it. So who wants to demonstrate the chip model in 3 minus 5? All right, you don't have to ask, you just come on. The answer is not 10 though. Can you do it?
Yeah.
Okay. It'd be funny if the answer was 10. Plays it right into his wheelhouse. What did he forget to do at the very start? That's fine. I just need to make sure you know, right? All right. When little Timmy, we don't even need to write the answer, right? The chips are the answer. And little Timmy looks at that. Of course, you're walking through it. He's not saying, here Timmy, read this, figure it out. Is it clear enough how the chips were used? I would say so. Just something to show that you've actually used the chip model, because the actual arithmetic is trivial for us. But not for little Timmy. He needs those chips, or he can't find the answer. So imagine that. You're so dependent on these chips. You don't know the answer until you go through it all. It's hard to imagine. I can't imagine. Last one. What number is that? That was not number 2. That was number 3. Not that it really matters. We have 4 minus -2. One more chance for a volunteer. You're going to sit there later today and think, oh, only I took my chance. No, I will never have a chance. Don't live with regret. There she goes. She doesn't want that regret. Plus, it's super easy as well. What's the first step? Not that you forgot, I just wanted to check. It's hard to relate how difficult some things are when it's so easy for us. It's hard. It makes it much more difficult almost. It's not trivial to explain something like that. There you go. She chose to not use any words. She's a person with few words, but that's okay too. You've added the pairs that you need to take away the 2 negatives. You have your key there, everything's good? Everything is good. I don't really want to start the next chapter. I don't feel like it.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.